Okay. Now we have also concept just now explained earlier. Here mentioned the slide where you have regularization, right? Where we're talking about regularization. So what is regularization? Regularization is a technique used in machine learning and statistical modeling to prevent overfitting. So it's a technique that is used to avoid overfitting, to help you to reduce or avoid overfitting inside your data set. Clear? So again, regularization helps you to reduce overfitting. So going back to the example of decision tree, if I notice my decision tree has overfitting, then how I regularize my decision tree? Just now we mentioned. What do we do? Yes? Sorry? Give more tree. How about depth? You remember just now I talked about depth. What do I need to do in depth? Give more restriction. Reduce the value of depth. So maybe depth, I see my tree has built depth up to, let's say, 20. And I find I have overfitting. So probably one solution is to reduce. And instead of depth 20, I go put maximum depth is, let's say, 15, and then I retrain my model again and see whether overfitting is reducing or not. If reducing and still have overfitting, then I reduce further. Maybe I go to 10. Still overfitting, I reduce more, reduce more. So this technique where you are enforcing restriction on the model here, this is called restriction because I'm putting restriction. I'm telling the model, hey, you cannot grow too much. Only the maximum level of depth is 15 or 10 or 5. So this is, we call it regularization. Clear? How about linear regression? The one we discussed earlier. Some algorithms, they have the technique, they allow you to apply regularization. Some models, they have no capability to enforce regularization. You cannot enforce restriction. Decision tree can, because it has depth. So we can set depth. But some model, they don't have depth, for example, assuming they don't. If decision tree has nothing to put constraint, then can I call decision tree is one of regularized model, meaning the model that can be restricted? No. One example is linear regression. Linear regression, they call it vanilla. Vanilla or plain regression or vanilla regression. It doesn't have any way to regularize it because it doesn't have any way to constrain the model. To put restriction, there's no way. Okay, clear? So if you want, if you have overfitting case with linear regression, then what do you need to do? You cannot do anything. So better avoid using linear regression. Okay, as a rule of thumb, don't use models that do not accept regularization. Look only for models that can be regularized. Okay, then you may say, then sir, how I have regression problem, then what do I need to do? There are other versions of linear regression. You have ridge regression, you have lasso regression, other versions. All of them are regression. But the difference between them, these two, they can be regularized. This one cannot be regularized. If cannot be regularized, then you don't have a way to reduce overfitting. Okay? Ridge and lasso regression, they have a technique. They have a technique. They have one hyperparameter called alpha. Alpha is a way to penalize your model. So penalize, put restriction, all same words. Okay? That means you can regularize your model by setting penalty to your model. Setting penalty to your model. Maybe later I show you why. Okay, so as fast way just to go through this. So ridge regression is also called Tikhonov regularization. Have you ever heard of this name? Tikhonov regularization. So now if you like to challenge people, go tell them, please use Tikhonov regression. They say what this person is talking about. Okay, so it is a regularized version of linear regression is used to avoid overfitting. By setting the value alpha, as I said, it has term called alpha. While linear regression, the vanilla regression doesn't have hyperparameter called alpha. So you cannot regularize your model. Lasso is also same, but Lasso also has some extra thing interesting than regression, ridge regression. So Lasso is also regularized linear model to prevent overfitting. Lasso regression is similar to ridge, but it can shrink the estimated coefficient to exactly 0. What do you mean estimated coefficient? What do you mean by coefficient? Theta, beta value, right? You see many terms, all same thing. So this one, estimated coefficient means theta, okay? They have the ability to shrink estimated coefficient to be 0, exactly 0. Ridge also has the ability to shrink, but cannot be 0. Why having 0 coefficient can be useful? Remember when we talked about feature selection just last week? Feature selection, simple feature selection. What do we mean? What do we want? What do we do in simple feature selection? We select fewer features than the overall features. Any reason why I need to do this? Yes, you may have irrelevant features inside your data set. Like ID, the student ID is a irrelevant feature, correct? Now, if you take it with linear regression is going to consider it as one of the feature, vanilla. Ridge regression is a bit smart way, is going to find ID is irrelevant. Then when it's look for its theta value, it's going to shrink its theta value, but still have value, which actually doesn't make sense. So maybe theta value is going to be, let's say, 0.1. Very low, maybe even lower, shrink. But again, is ID relevant feature? No. So meaning theta should be exactly 0. Okay? So going to lasso regression has the ability to set theta to 0. So back to simple feature selection, what is the first approach or the third approach we talked about? We said that we have filter approach, embedded approach, and some approach in the middle. Filter approach where yourself select the features. Embedded approach where the model, the algorithm itself has the ability to select features. So lasso regression actually has the embedded approach. Embedded approach. Because it has the capability to shrink the coefficient to 0. So what would happen if I have here ID, let's say predicted Y equal theta 0 plus, okay, plus 0 here, which is theta 1. What does it mean? That means whatever the value for ID has no impact whatsoever on predicted Y, right? As if the algorithm internally has excluded this feature. Correct? So this is why this is one of the embedded approach. Lasso regression has the ability to select the features. So this means lasso approach used for feature selection. This is just what we mentioned earlier last week. So it has the ability to do feature selection where it can select, identify some and discard a relevant feature from the model. Okay? Okay? Attention. That means here's something important to pay attention to. Scaling the data is crucial when you have regularization model. So scaling the data is crucial when using regularized regression, as this model is highly sensitive to the scale of the input feature. So as a rule of thumb, regularized models like ridge regression, like lasso regression, they are sensitive toward the scale of the input features. to assume all features, to make all features have equal footing, equal impact inside the data set during modeling time, we apply feature scaling, right? So we apply feature scaling, such as standard scalar, for example, or we apply standardization or normalization, okay? This is applicable to most regularized model. To address the issue, it's recommended to use standardized scalar, for example, or similar method to ensure that input features are scaled appropriately, meaning they have equal footing. They have equal footing before training your model. Okay? So as a rule of thumb, linear regression, meaning without regularization or the vanilla one, versus ridge or lasso, which one you should choose? Firstly, as a rule of thumb, linear regression, the vanilla one, you should avoid all the time. Then how about ridge or lasso? Take both and then see which one do well. But if you like to have more idea, so as I said here, it's almost always preferable to avoid to have at least, it's almost always preferable to have some regularization. So generally, you should avoid plain linear regression, the vanilla one. Try to avoid. Ridge is a good default. Use also lasso. So ridge is good if you suspect that only few features are useful. Okay? Sorry, if you suspect you have only few features that are useful, then you should go with lasso. If you suspect you have many irrelevant features inside your data set, so as a better idea, go with lasso immediately. Why? Maybe you don't know which features are relevant, which one are not. You are just rushing very fast. You need to build a model. Then go probably with lasso, because lasso has the capability to select the important features and drop the irrelevant ones, while ridge doesn't have this capability. We have also elastic net as another model. Maybe later I explain about it. But anyway, so you have elastic net, you have lasso, because they reduce the useless features. Okay. Lasso you use when you have large number of features, but you expect only small subset of them are relevant. Then go with them, because it's going to shrink the coefficient, the estimated coefficient, to 0. Mean theta, you can have thetas with 0 value. But anyway, if you are interested, just take both. Doesn't mean you have only to choose one. Take both, see which one is working better. As a rule of thumb here, it's already given to you.